Good morning, grade 10 math class. It's Mr. Armishaw here. Let's get right into lesson 5.3, common factors. First thing we'll start off with is a Mad Math Minute. You can see it right there in front of you. I'm going to pause the video right now and give those questions a try. Okay, now that you've given them a try, I'll show you the answers. Take a look at them. The first example, I've kind of shown the long way of figuring this out. If you want to use those patterns up above, this is the long way to kind of figure that out. And then for the rest of them, I've just kind of written the answer down. Okay, so in the last couple of lessons, we've been doing a lot of multiplying polynomials. Right now, we've had simple questions like this, where you would multiply a factor out front by everything inside the brackets, right? So this is stuff that probably brings you back to grade 9. We did a bit of that. We did some special products. You guys worked on FOIL, right? Multiplying out, what happens when you've got something like this. X plus 3, x minus 2. All right, let's do first outside, inside last, right? So first outside, oops, that should be a minus. Inside, last, and then simplify. Okay, so this has all been multiplying that we've been doing. What we're going to start doing and spend the rest of the unit on actually is factoring. And all factoring is actually the exact same thing in reverse. Okay, so we're going to start with something like this. Oops. Let's put that in red. We're going to start with something like this, and we're going to work our way backwards to something like that. Or something like this, and work our way backwards to that. There's a bunch of different ways to do this, different methods, different kinds of expressions that the methods work for. And so we're going to work a lot on that. And these skills are important for a bunch of reasons. One is in the unit in the next couple of chapters we're working on, we're going to be working on quadratics, which is a really specific sort of equation that we can graph and play with. And we're going to be looking to take expressions like this, equations like this, and convert them into equations like that, and vice versa. So that's one of the reasons why we're learning the factoring that we're learning. That's how we'll use it right away in grade 10. However, these factoring skills will be very useful to you going forward in math, not just for quadratics, but for solving all different kinds of equations. So this is a really fundamental math skill, kind of like when you learned how to add, and then you learned how to multiply, and then you learned some basic algebra and stuff like that. This is another really basic math skill that is worth spending the time on, becoming really good at. So let's get started. There's a bunch of ways we're going to do this. First one we'll start off with is just finding a common factor that is a monomial. So if I go back to that example earlier, we can see here that in the expression 3x cubed plus 3x, the factor that's common to both of those terms was actually 3x. What we're looking for, I'm going to rewrite it so it's a little clearer here. What we're looking for is the greatest common factor to all of the terms in the expression. Now I know you guys are used to greatest common factors in terms of numbers, right? So the greatest common factor of 3 and 3 is, well, it's this 3, right? But we're also going to be looking for greatest common factor in terms of variables. Now, this has got an x times x times x, so there's 3 x's there. This one's only got the 1 x. So what is common to both of these terms is a single x. So we're going to say the greatest common factor for these two terms is 3x. All that really means is you can divide 3x into both of these and come out on the other side with something that's a whole number. So if I were to divide both of these by 3x, let's see what that would turn out to be. So 3x cubed divided by 3x is just x squared. and 3x divided by itself is just 1. Just like that, right? Now where did the 3x go? So actually let's write that down. So what we're going to do is we're going to write down our greatest common factor first, and then in brackets we're going to write down what the remainder is once it's been divided into both terms, right? So we had x squared plus 1. We'll go back to the worksheet here and we're going to work on a bunch of other examples. Okay, so let's take a look here. And again, feel free to pause the video at any point and try the question on your own before you watch me do it. So greatest common factor to 8x and 4, well 4 goes evenly into both 8 and 4, and there's an x here, but there's not an x there. So that means x is not common to both terms. So our greatest common factor is going to be 4. So if I divide both of these by 4, I'm going to write that greatest common factor down first. So 8x divided by 4 is 2x. 4 divided by 4 is 1. And we're done. Let's do it again. So x squared minus 3x. So this is an invisible 1 here. And then there's a 3. So greatest common factor is just 1. And then here we've got an x squared and an x. So the greatest common factor is just going to be x. So if I divide both of these by x, I'm left with x minus 3. Now I've been writing down this divide by thing. You don't actually have to do that. I've just been doing that to show you what it is we're dividing by. I'll do that a couple more times and then I'll stop doing that. So let's take another look here. Pause the video for a second, see if you can come up with the greatest common factor. Okay, hopefully what you came up with was 8x. You can see that 8 goes into 16 and 8, and x goes into both x and x squared. So let's divide by our greatest common factor, and what we're left with is 8x. All of that multiplied by 2x plus 1. Alright, now these expressions below, I mean, they look scary, but they do not have to be scary. We just want to look at what numbers and what variables are common to each of them. Okay, so again, greatest common factor. So 7, 21, and 28. Hopefully I can see that those are all multiples of 7. So this is going to be 7 something. How many c's? I've got 1, 2, and 4, so 1 we'll divide in. And then d, I've got 3, 5, and 3. So I can actually divide d cubed, or 3d's, out of it. So I can divide 7c cubed out of all three of those terms and still be left with some whole numbers. So let's write it down. 7c d cubed. Okay, so I write down my greatest common factor first, and then I'm going to start dividing. Okay, so 21 divided by 7, 3. C4 divided by C1, that's C cubed. D cubed divided by itself is just 1, so it kind of disappears. Okay, 20, so this is a negative 4. C D squared. And then 7 divided by itself is 1. C divided by itself is 1. D divided by itself is 1. So 1 times 1 times 1 is 1. And that's it. That's kind of an ugly expression, but it's not really any harder. It just takes a little longer. Alright, pause the video again and try this one on your own. Okay, hopefully what you came up with was the greatest common factor of 17x squared. Now, here's a trick. There's a y cubed in this term. There's no y in that term. That means that y is not common to these terms. And same with z. Z is not common to both of these terms either. So we can only take a 17 and an x squared out of them. So let's write down our greatest common factor. Alright, so 17x squared divided into that is going to leave me with y cubed. And then here I'm going to be left with minus 3. I still have 1x left, right? So that's an x cubed divided by an x squared. So I'm left with 1x, and all the z's are still left over. Now, if this is not making a lot of sense to you, this whole dividing into thing, it might be helpful to try something like this. What I'm gonna do is I'm gonna do this this question C again on another page, and I'm gonna kind of spread it out. If this makes sense to you, feel free to skip the next minute of video or so. All right, so let's erase this here. Get rid of all this stuff. Okay, so let's try this one. For those of you this has not been making sense for, I'm going to spell it out really slowly here. Okay, so what I have here is I actually have 16 times x plus 8 times x. And if I want to divide that by, what was my greatest common factor again? It was 8x. Okay, so if I'm going to divide that by 8x, what I'm really doing is I'm dividing each term by 8 times x. 8 times x. Okay, so we know when we divide something by itself that it equals 1, so they kind of cancel out. So these are going to cancel out. These are going to cancel out. These are going to cancel out. And all I'm left with here is, well, 16 divided by 8 is 2. I've got 1x left. And then these all canceled out, so that's just going to be still 1. Anything divided by itself is 1, right? Hopefully that helps make sense of what's going on here when we divide by those terms. Okay, back to factoring. So that's how you factor a single monomial out. So now's a great time for you to get your textbook out and try your homework questions for today. Again, that's Common Factoring, page 234, the questions that are on your unit outline. All right, we'll see you guys tomorrow.